Hello everyone. This is the part 9 of Unit 6. In this video, we will study about mutual waiting, shadow paging, resource deadlock, communication deadlock, difference between resource and communication deadlock, and we will see past exams questions. Mutual waiting. Mutual waiting is a deadlock condition where each of a group of processes is waiting for a message from another member of the group, and here no messages in transit. Shadow paging. Shadow paging is a technique to maintain data consistency and enable crash recovery. It maintains two page tables during the lifetime of a transaction, that is, current page table and the shadow page table. Store the shadow page table in non-volatile storage, such that state of the database may be recovered. Shadow page table is never modified during execution. This is an example of shadow paging. Here, page 2 and page 5 are modified. Resource deadlock. In resource deadlocks, processes can simultaneously wait for several resources and cannot proceed until they have acquired all those resources. A set of processes is resource deadlocked if each process in the set requests resources held by another process in the set, and it must receive all of the requested resources before it can become unblocked. This is called resource deadlock. For example, suppose a system is running two processes, P1 and P2, and they want the resources R1 and R2. Here, the P1 process holds resource R1 and waits to get R2 resource, while process P2 holds resource R2 and waits to get R1 resource. In this way, P1 waits for P2 to complete and P2 waits for P1 to get complete, and hence a deadlock occurs. Now, communication deadlock. Processes in this deadlock wait to communicate with other processes in a group of processes. A waiting process can unblock on receiving communication from any of these processes. If each process in the set is waiting to communicate with another process in the set, and no process in the set ever begins any additional communication until it receives the communication for which it is waiting, the set is communication deadlocked. For example, suppose process A waits to get a message from process B waits to get a message from process C, and process C waits to get a message from process A, and hence, a deadlock occurs. Difference between resource deadlock and communication deadlock. Resource deadlock is not directly known which transaction depends on which other transaction. Communication deadlock may know the identification of the processes from which it must receive a message to communicate. In resource deadlock, a process cannot proceed with the execution until it receives all the resources for which it is waiting. In communication deadlock, a process cannot proceed with the execution until it can communicate with one of the processes it is waiting for. In resource deadlock, waiting is done for resources. In communication deadlock, waiting is done for messages. If each process in the set seeks resources held by another process in the set and must obtain all the requested resources before it can become unblocked, the process set is resource deadlocked. If each process in the set is waiting to communicate with another process in the set, and no process in the set ever begins any additional communication until it receives the communication for which it is waiting, the set is communication deadlocked. Resource deadlock can be prevented by a safe state. Communication deadlock cannot be prevented by a safe state. In resource deadlock, processes can simultaneously wait for several resources and cannot proceed until they have acquired all those resources. In communication deadlock, processes wait to communicate with other processes among a set of processes. Now, we will see the past exam questions.